Good afternoon and welcome to today's science lesson. It said that in that lesson we said that today, the science lesson, we shall deal with the ethics and organ donation. We shall try to see what rules and regulations are there when we are dealing with organ donation. We are going to simply ask ourselves questions that are important when it is dealing with organ donation. If there are many people that are lined up and they require some organs to be donated to them. Now, if you have 10 people, and these 10 people, all of them, they require a kidney, whom are you going to pick that now, let me donate this kidney to so and so? What rules are you going to use to say the organ should be given to so and so and not to so and so? This is now when we say ethics come in and organ donation. Past history or the report shows that many as 20,000 people receive organs transplant in each year. They perform close to 20,000 transplant. They are given these organs. But apart from the 20,000 people who receive organ transplant, we are told close to 100,000 people they miss out from this organ transplant. They are waiting to be given, to be donated, to receive some of this organ, but they miss out. Why? What rules are there that these people, the doctors, use to choose the 20? How are these 20,000 chosen from the 100,000 that need organ transplant? We are saying that when we talk about 100,000 organ transplant that are required maybe to be done in a year, we are saying where they will differ depending on which organ. Some of organs that can be carried out, some of organ transplant can be carried out is the heart. Heart organ can be transferred from one individual to another. We can also talk of the kidney. Kidney can be transferred. We can talk of the liver. We are told, the scientists have proved that the liver of a pig can work very well among human beings. Now, what rules are there also to ask ourselves? Should we pick some of the organs that are among animals and transfer them to human beings? Is it ethically correct? We are going to question ourselves and discuss some of important questions that guide organ donation. And among these many thousands of people that are waiting for organ transplant, there are many people also who die. There are many people who also die. They die because they were in line waiting for this transplant, but they don't get the transplant. They are waiting for people to donate some important organs for them, and it's late. By the time you are donating an organ to assist somebody, you find that this person has waited for too long and has died. So there are many people who die before this organ becomes available. So what should we say? We are saying, we are asking ourselves, who should receive a transplant organ? Given the shortage of donor organs, some people have unfortunately taken the task of deciding who to receive the organ and who not to receive. It is as if they are deciding who to be given an organ to live and who not to live, who should be left to die. When a question reaches there, then there are some fundamental questions that we need to consider when we are deciding who to give an organ and who not. Some of the questions that form the basis of such institution when they are trying to transplant organs to many people that are waiting for organ transplant. One of the questions they ask themselves, who has the most urgent medical need? So if there are 10,000 or if there are 100,000 people waiting for organ transplant, before you choose whom to give that organ transplant, one of the questions you should ask yourself, who has the most urgent medical need to receive that particular organ? Another question, there are many people have lined up to receive organ transplant. Another important question is, how important is each person to the community? These people that want to receive organ transplant, how important are they to the community? If they receive this transplant, this organ transplant, and they continue to live, will they continue assisting the community? Were they important to the community, or they were useless? Another question you need to ask yourself before you decide whom to give an organ transplant. Is this person, is he a smoker? Is he a person whom you will give an organ and the next day has destroyed that particular organ? So there are questions, what is the lifestyle of this particular person? Is he a smoker? Or another question that you can rationally ask yourself, has he ever attempted suicide? You know, if this person who wants to get an organ transplant is needing one, but several occasions he has been attempting to destroy his own life, what is the need to preserve his life if he has been attempting to kill it? Should we choose others who have never attempted committing suicide? So these are fundamental questions that will guide the institutions that is deciding whom to give a transplant organ. What about another question you're asking? Is this person who is supposed to receive a transplant organ a prisoner? Has he been sentenced for life or for murder? Has he been sentenced for capital punishment supposed to be killed? You know, it can be useless for you to give an organ to somebody who is serving a capital punishment. He might even be killed any moment, and you decide to prioritize him and to give him an organ transplant. What will be the need for you to give somebody who will be killed in a few minutes? Others will say, let us give him, he will die, then we shall remove that organ and give it to other people. But it will be a wastage of time and so forth. So these are some of the questions we should ask ourselves. How much effort has each person contributed to the society and to their lives? Has this person contributed to the society? Has this person contributed to his own well-being? How much has this person contributed to his own life? These are fundamental questions and important questions that we need to ask ourselves. How much can they pay? Organ transplant are expensive. It is not a cheap work. No, it is expensive. Now the question is, are these people who are to receive organ transplant, how much are they willing to pay? Are they able to meet the cost of those particular organs and so forth? These are fundamental questions we need to ask ourselves. Another question is, how long have they been waiting on the list? Okay, there are 10,000 waiting particular organ. How long has he been waiting? Should we also bring people who just came recently to be on the list, and we take those who have waited for a long time? How long have they been on the waiting list? That is another question we can consider when you want to do an organ transplant. How long have they been on the waiting list? Another question that is fundamental to ask on organ transplant is, how long? We talk of longevity. Who is most likely to live longest when they receive this transplant? Then maybe we're talking of age. Are you giving this organ transplant to a human being who is 96 years old? Or are you giving this organ transplant to a human being who is 18 years old? So when we talk of how long are they going to live after they receive a transplant, you are considering, are you giving this organ transplant to a young person who can still be beneficial to the society, or you are giving it to somebody who is old age, and the aging has crept in? And we know people also die due to aging. Aging is a process that can cause death. You can die because you have aged. Are you transplanting this particular organ to somebody who is very old or very young? So age is another factor that can be considered. And then we ask ourselves during the organ transplant, is this the first time for them to receive an organ transplant? Or they have received other organ transplants before? Is this their first time, or this is the second time? That's another factor we can consider. There is a situation whereby you can continue giving a particular patient or a particular person, maybe other organs are killing other organs within the body. So we have to ask ourselves, is this the first time this particular individual is receiving this, is in need of this particular transplant, or there are times when he has been given a transplant before? We need to ask such a question. Then the question of attempting suicide, yes, you have to know the history of these people. Have they attempted suicide before? If yes, now, do you want to preserve a life of such a people who have been attempting to commit suicide? It's another question. And then we are saying, are they prisoners who are serving life sentence or who are serving capital punishment and so forth? We want to know. These questions are important for us to ask ourselves because of shortages of organs. Shortages. There are very few people who are willing to donate their organs to assist other people. And the question we ask ourselves, who should donate? Who should donate? That question can be asked very well, who should receive? Should you be in the receiving bracket? You are ready to receive body organs from others to sustain your life, but you are not ready yourself to donate an organ to assist others. We should reach a level whereby anybody should freely donate and anybody should freely receive. So these are some of the questions that we consider. Then we are asking ourselves, at the moment, organs can only be donated by people at the moment who have consented. At the moment, only people who have consented that they will be able to donate their organs will receive the organs from them. If people have signed that, please, when I die, let these organs be removed from me and assist people who are needy. Such a people, their organs will be taken. That's one. Two, if the family of the deceased, the families of the deceased, they come in, they say, yes, this is our deceased person, but we would like this deceased person to donate the organ. They can sign and hand over the organs from the deceased. Only the families of the deceased. That is the rules as now. The cases are that way, that the family of the deceased can be able to donate the organs of the deceased person to assist the people who are in need, who are still alive. Or maybe the deceased person, if he had consented earlier and signed that in case I die, then let my organs assist people. So far, at the moment, what we're talking currently, organs are only received from people who have consented or from families who can say, yes, this is our patient, this was our person, the deceased member of our family is dead, but let the organs assist others who are still alive and so forth. Now, we want you to consider the following. One, some of the questions that we should consider. One question is, should organs of deceased people be used? Should organs of deceased people be used? If the organs of deceased people are used, under whose authorization? We are saying the families of the deceased can authorize as it stands now. And if they don't, it is maybe if the deceased, while he was still alive and he authorized that these organs can be used, it is okay. Another question we should ponder is, should be considered social responsibility of the people who donate organs. How should we consider these people who are donating organs? What is the social responsibility of people towards these people who donate their organs? If you donate your kidney and so forth. And another question we should ask on organ donation, should people be allowed to sell part of their body organs? It is another debatable question. You can find somebody, you have 2 kidneys, you are poor, you have some debts, and you feel there are people who are buying these body organs. Should people be allowed to sell part of their body organs to pay some debts or maybe to ensure that they continue to live depending? Should people be allowed? It is an ethical question whether people should be allowed to sell part of their body organs. Another question we should ask ourselves in organ donation is, should there be programs, should there be education programs that will advise people on the need of donating organs? Should there be education programs that will tell people reality as far as matters to do with organ donation is concerned? What I'm trying to pass across is, people seem naive, people are innocent, people are not aware that they don't have proper information when it comes to organ donation. People will come up with their cultures, that in my culture, when I'm buried, I should be buried with all my organs. If it is my teeth, I should have them. If it is my eyes, I should have them. So that when I'm dead, in the living dead world, I still have my eyes. We don't know whether that is true or not. But the question here is how our cultures are affecting organ donation. So we are saying, should people be given education on organ donation? The question here is, there should be more information that deals with organ donation so that people have information. The more information people have on organ donation, they will be able to make up proper decisions as far as organ donation is concerned. Another question is, should religious people be allowed to opt out of organ donation? Should religious people be allowed to opt out of organ donation? Now, if we talk of religious people being allowed to opt out of organ donation, now we are also saying that these religious people, when they are in need of organ donation, they should not be given organ transplant because they have opted out of organ donation. Therefore, they should not receive organ transplant. Is that rational? Are there religious people who are ready among the 100,000 people on the list who are waiting for organ transplant? Are there also religious people? Are they religious? Do we have religious people among the 100,000 who want to receive organ transplant? If yes, then the religious people should not opt out. You will only opt out from organ donation if also you have said, well, if my organs fail, I should not also receive organ transplant. But if you are willing to receive an organ transplant, you should also be ready to do what we call organ donation. And organ donation, people can be taught and be informed that in case of an accident, in case of death, let me not be buried with organs that can assist others. If they are able, then let us assist people. Life is precious, life is important. We can support life. Another question we should ponder about is, should families be paid to help? Should families be paid to cover the funeral cost if they donate some of the deceased organs? Deceased organs. We are saying, if families are unable maybe to bury the particular deceased person, should they be allowed to sell part of the organs before they bury that individual person? They sell the parts of the organ of the deceased person and use the money they have acquired for funeral expenses of that deceased person. Should families be allowed to sell some organs so that they can give the deceased person a benefiting burial, a good send-off? That is another ethical question that people can debate and ask themselves. What about, we talk of the foetus. We have aborted foetus. We have abortion. Should the organs of these aborted children be used to assist the lives of people? That is another question that we need to look into, because in some countries they have allowed abortion. It's the order of the day. Should kids that have been aborted, the organs be used for the survival of people who want to survive or who have problems with their body tissues and organs? That's a question that we need to ask ourselves. Then the last question that we need to debate and to know the appropriate answer. Should we also, it has been proved medically correct that liver particularly of pigs, if you have a problem with the liver, a liver of a pig can work 100% with the liver of a human being. So if you have a problem with the liver, should you be allowed that you use the organ of the liver of a pig so that it is transplanted on you? Should we allow human being, you get some organs from animals and we transplant them to human being? Because some of them, like the one of a pig, can work very well on a human being. Should that one be allowed? These are the questions that we need to ask ourselves in organ donation. Should we allow to pick some of the organs from animals so that we can benefit and we continue existing, being alive? We have said pigs' liver can work very well. Then we are talking of research has shown that they can come up with artificial organs. Should the scientists be allowed to come up with artificial organs so that when our organs fade, we can replace them? And we talked of cloning. On cloning, we said it's another science whereby some body tissues can be cloned in laboratories. Some organs can be cloned in laboratories. Should such a science continue so that whenever we are in need of organs, then laboratories that have grown up these body organs and body tissues can be taken. We take these body organs and we replace the ailing ones that we have. So should scientists be allowed to continue on cloning, on stem cells, so that we can get some body organs that can benefit us? Those are particular important questions that question of organ donations is dealing with ethics and organ donations. There are rules that will govern people who are waiting for transplant and so forth. And we ask ourselves, who should be given this liver? Who should be given this particular organ? Is he important to the society? Can he contribute? Can he be able to pay for that organ transplant? Costs of transplants are high. Is he able? So there are many questions that will continue governing the institutions that deal with organ transplant. Now, let us now advance to another topic. This topic is identifying some specialized cells. Yes, identify we want to talk slightly on specialized cells. Then when we talk about these specialized cells, we shall see how cells and disease control are connected and concerned. Now, when we talk of identifying some of the specialized cells, there are some cells. We talked of animal cells, yes. Even when we talk of a human being has cells, but these cells are also different. They have particular functions. For instance, if we are talking about human beings, even plants have different cells for different functions. And some of these cells are specialized to perform a particular functions. For instance, we know if we are comparing cells of a plant and animal cell and plant cells are not the same. But let us give for instance, if we are talking about animal cell, for instance, nerve cell. Nerve cell, because of its function, nerve cells, because of its function, is structured in a way that is different from other cells. Nerve cells have dendrites. I will just explain. If we have to draw a structure of a nerve cell, you will see something like so. And it has dendrites, maybe, and then subdivisions. Now this is nuclear. That's the nuclear, and then we have the cytoplasm. When we're talking about animal cell, we have the mitochondria, where the power and so forth. Now these are dendrites. Look the way they are structured. The nerve cells are structured in a way that they have dendrites that are ready to transfer electronic impulses from one body part to another. So these cells are specialized for their functions. What is their functions? To carry nerve impulses from one section to another. To carry nerve impulses, whether from the body to the brain, so that the body can interpret. Was it the heat? What was it? Was it touch? Was it the pressure? Was it high? So they have to carry these impulses to the brain so that the brain can interpret exactly what had transpired. So you find that they are specialized to perform that particular function. For instance, if we are also talking about animal cell, we talked of red blood cells, for instance. Red blood cell. And we say red blood cells is also specialized for its function. One, we said that red blood cells, they do not have nuclear. They do not have nuclear. They are tiny, they do not have nuclear, but they have a red pigment called hemoglobin. That red pigment called hemoglobin, it enables these red blood cells to carry oxygen. To carry enough oxygen in the form of oxyhemoglobin. So it is specialized the way it is structured. It is tiny and it has more space to the extent whereby it does not have the nucleus, so that it can carry much more oxygen as possible. That is red blood cells. For instance, if we are talking about If we are talking about maybe, we have only given this an example of animal cells. What about if we talk about the plant cell? You find, if you are talking about plant cell, we can look at an example of a root hair cell. Root hair cell, you'll find it has some, it takes such a shape. So it has some thin projections. These thin projections, they increase the surface area. Root hair cell is made in such a way so that it can be able to carry out a process of division or osmosis. It can be able to absorb the nutrients from the soil, to pick the correct nutrients, whether it is nitrogen, whether it's through the nitrogen from the soil, it can be able to convert it and take it into the plant. So it is made in such a way that it has larger surface area for division to take place. It is specialized for its function. Take about the leafy cell. The leafy cell, you find that they have a lot of stomata at this, under the leaf to carry out their functions well. We can have an example of if we talk of human being, we can talk of maybe white blood cells. White blood cell, we say it is irregular in shape. That is nuclear. Now, if that is the nuclear, and this is our cytoplasm, for instance, this is white blood cell. So we say, these white blood cells, it is like so, it is irregular in shape because at any given moment, because its major purpose is to fight antigens that are trying to attack the cell. So it is regular shape, it is able to engulf any protruding germ that is coming towards the body. It is able to engulf that germ and kill it and digest it. That's why it has got that irregular shape. It has a regular shape for it to make it possible for it to fight the attacking germ. Any germ that will approach it, it will be able to engulf it and kill it. And therefore it has this shape. It is specialized to perform its functions of killing the coming antigens and the germs that are trying to attack the body. Therefore, that shape. We can also have another shape, for instance, if we can talk of another specialized cell before we deal with this. Another specialized cell, for instance, sperm cell. Look, sperm cell, it has a tail and it has a head. So this is the nuclear, and this is where we have the mitochondria. Mitochondria is within the cytoplasm. Why does it have this tail? It is specialized in its activity of swimming. It can be able to swim and go further to fertilize the ovum. So it is specialized in its function. When you compare now the sperm cell and the red blood cells are not the same. When you compare the sperm cell and the white cell are not the same. So we have cells that are specialized. When we talk of the ovum, look the way it is, so that it has more space and it is adapted. Once it is fertilized, you find the ovum is also different, for instance. It takes that shape. Once it's fertilized, it is made in such a way that other sperms cannot penetrate through. It's only the first one. Only the first one will be allowed. So we are seeing, and it has more, the egg cell has got more support. It will be able to support the zygote in growth, in cell division. So we have specialized cells. They are specialized because they are made in such a way that they can be able to perform their function effectively and efficiently. So if you talk of, if we're talking of plant cell, the leafy cell, you find they have a lot of stomata. The cells are there, and they have that chlorophyll matter. You find there are many. They can be able to trap the light from the energy. They can be able to trade the light from the energy to make energy and to make their own food. So you'll find that there will be a lot of cells ready to trap light from the energy. And they are specialized. They have more space for vacuole and so forth. Now, we have mentioned something slightly on identifying some specialized cell, but now we want to deal with cells and disease control. Cells and disease control. It is important to mention the following, that there are two types of specialized white blood cells called B cells and T cells. It is important to note that there are two types of specialized cells. One is called B cells, the other one is T cells. We are dealing with, when we talk of disease control, our point of concern and with cells, we are trying to look into the white blood cells. We are looking into white blood cells because white blood cells are concerned with fighting diseases. So if we want to control the diseases, then we have to see how white blood cells behaves. We have said there are two types of white blood cells that are specialized. We are saying these white blood cells, we have the B cells and we have the T cells. We shall want to discuss and to know what are the functions of these white blood cells, the B cells. What are the functions of the white blood cells, the T cells? What are the roles? What happens exactly when an antigen, when a germ attacks the body? We are saying these cells are involved in immune response. We are saying the B cells together with the T cells, both of these types of white blood cells are involved in immune response. Both of them, they assist in destroying the invading foreign material. Any foreign material or any germ that is trying to invade the body, then it is the responsibility of the white blood cells, that is the B cells and the T cells. They join hands to ensure that they fight these foreign material that is trying to attack the body. We had said that white blood cells are produced in bone marrow. We had said that white blood cells are produced in the bone marrow and they are released into bloodstream. We had said something on white blood cells when we were comparing with the red blood cells. We said red blood cells, there are many in number, but when it comes to white blood cells, they are fewer but bigger in shape. When you compare their size, they are big. They are not as tiny as the red blood cells. So both the red blood cells and the white blood cells are produced in the bone marrow. When they are produced from the bone marrow, they are released into blood streams to play a specific role of ensuring that germs do not attack the body. The germs are not present in the blood. Now, the B cells, the white B cells are produced by antibodies that are specific to each particular antigen. So what we are talking about the B cells, any type of a germ any type of antigen is a germ that is trying to attack the body. An antigen is attacked by an antibody. So let me continue. What I'm saying, the white blood cells called the B cells. So antibodies that the B cells produce particular antibody for a particular antigen. Each antigen is faced with a particular antibody to fight it. So we are saying B cells produce antibodies that are specific to each particular antigen. Any chemical substance that triggers the immune response in the body. So we are saying that these B cells, the white blood cells, the B cells, it is a response. It is a white blood cells, yes, the white blood cells, when they are responding, when they are trying to fight the antigen, they will produce these B cells, and these B cells, they give immunity to the body. So we are saying each B cell will produce a specific antibody to deal with a specific antigen. Then this B cell will be stimulated. The stimulated B cell will divide to form plasma cells and memory cells. So when it is triggered, it will produce plasma cells and memory cells. Shall explain why the role of this B cell, the memory cell, and the plasma cells. What is happening about this antibody, these white blood cells that has produced the B cells? In case of a further attack, the memory cells will be able to know that this is the antigen I fought with. Therefore, the immune response will be high. Immediately, the body will be triggered, and there will be more B cells that will be ready to attack it. So the memory cells are very important. There are plasma cells, they have their role, but the memory cells, they live longer, and they are there waiting. In case of a similar antigen attacking the body is well equipped with that information. That's why they're called the memory cells. They live longer. They don't just stay for a few hours and die. No, they are there to wait. As long as a similar antigen will attack the body, then these memory cells will be ready to fight that particular antigen. So we are saying the stimulated B cells divide to form plasma cells and memory cells. The plasma cells produce antibodies which combined with an antigen, and the antigen is deactivated. So what the plasma cells is able to deactivate the antigen that was trying to attack the body. So the B cells is able to produce the plasma cell, and the plasma cell is able to deactivate the antigen that attacked us, while the memory cells is there to keep a memory. In case of a similar antigen that will attack the body, then more plasma cells will be readily available, produced to deal with that particular antigen that is trying to attack the body. So we'll find that memory cells will have a longer longevity in terms of lifespan than the plasma cells. The memory cells will live longer. In case a similar antigen will be able to attack the body, then the B cells will be activated to produce more plasma cells to deal with that particular antigen that had attacked the body. While the memory cells remember the antigen that invaded the body later, it stimulates much faster to respond to the body's body mechanism. So the memory cells are there to keep a history. Of that particular antigen that had attacked the body. So memory cells, it will be able to trigger the B cells immediately to produce enough plasma cells to deal with that particular antigen because it had attacked the body before. So the memory cells have that history, and they live longer to keep that history in case of a similar attack that happens. Now we are saying there are several types of T cells. There are several types of T cells. Some of these T cells, we call them the killer T cells. There are several types of the T cells. We have talked about the B cells. We are now want to talk about the T cells. We are saying there are several types of T cells. And these T cells, we call them the killer cells. We shall have a diagram trying to explain especially how the T cells work, how these B cells work, and so forth. So there are several types of T cells, the killer cells. They attack the antigen directly, injecting toxic chemicals in them and causing them to rupture and die. So the work of T cells is to inject, to attack the antigen and to inject them with some chemicals and ensuring that the toxic chemicals and causing them to die immediately. Then we have what we call helper T cells. So we have the killer T cells, then we have the helper T cells that help to activate. The helper T cells, they help to activate the B cells. B cells cannot function effectively without the T cells. The B cells cannot function effectively without the T cells because the helper T cells, we have the helper T cells and we have the killer T cells. So we are talking about the helper T cells because the helper T cells cause the B cells to divide and produce millions of antibodies, we are saying the helper T cells, they activate the B cells to produce millions of antibodies. And then from the helper T cells, we have what we call the suppressor T cells. In case they have attacked a particular antigen, and that situation has been brought under control, there are no longer antigens that are trying to attack the body. There are no longer any other cells that are trying to attack the body. So the body will not continue producing the antigen. There is a production of suppressor T cells that will be able now to bring the situation to hold that no more production of antibodies, so that the situation is now back to normal. So we are saying suppressor T cells, they stop the activity of the B cells. They stop the activity of the B cells when infections has been defeated. So if there's an infection, we are saying, yes, the helper cells are there. They will be able to activate the B cells to produce more antibodies to deal with the antigen that is trying to attack the body. But once the situation has been controlled, once the infections have been dealt away with, why more further production of antibodies? It will be unnecessary. So the suppressor T cell is there to ensure that now it suppresses, it brings the situation to normal, so it suppresses the production of more antibodies because the situation has been brought under control. Now we are talking of memory cells. Memory T cells also produce. Memory T cells are also produced so that the body remembers the antigen. So the memory T cells are important. They are produced so that the memory T cells are produced so that the body will be able to remember the particular antigen that had attacked it earlier. And if it remembers, then the response will be quick. They will produce more specific antibodies to deal with that particular antigen, and so forth. So we can have a simple diagram trying to show how this antigen, that is the germ, how it is fought very well by these white blood cells. We can have something like a star. Maybe that one, let us call that one an antigen. This is a foreign material. This is an antigen. How is it going to fight? How is it going to be fought by the white blood cells? So if that is an antigen, then we can have our B cell. We said white blood cells, we have this type of B cells, and the type of white B cells is concerned with fighting the antigen. And we can have that one as the B cell. Now this is the antigen, it is trying to attack the B cell. What will happen? So we can have our antigen here. Then we can have so we can see what is happening with the white blood B cell. We had said this white blood B cell, it has that ability, it is irregular in shape. It will be able to engulf the foreign material that is coming. So we can see this is our antigen and this is our antigen here. Now the white blood cells, the B cells, is trying to engulf it. And remember we had said it produces enough antibody, and each antibody to deal with a particular type of an antigen. So that will be the structure. So from here, we shall show a situation whereby if there were many antigens that had attacked these particular white blood cells, it will engulf all these antigens that had attacked them. So we can have such a structure. So we can see that all the antigens, they have been engulfed completely and they are within now the white blood cells. Now, what will happen when the plasma cells come in? Now, when the plasma cells comes in, they will come in and they will have such a structures, and you'll find that now they will be able to deactivate and destroy the attacking antigen, and the attacking antigen will be removed. So you'll find it will be here, the attacking antigen. Then the plasma, the white B cells will be able to multiply much in number because it causes cell division and more antibodies are produced. So from here we shall have such a structure. Then those are secreted antibodies. And you know there are millions of them, so they will be able to capture all these, the antigens that were existing. So we can see what is happening. What will happen now if we were to have the fourth structure, which you can easily have it. This will be showing clone of memory cells. So clones will be memory cells will be clean. Here we shall not be having. We shall have the antibodies, but the antigens already they have been destroyed. So what happens when an antigen comes in? It will be met with the B cells, and these white B cells. With enough antigen, it will be able to engulf this particular antigen that has attacked this germ, and it will be so within it. And then the antibodies will be produced. The secreted antibodies will be able to remove this, and it finally remove all the antigens, kill them. Then the cell will remain. The white blood cells will be remaining with cloned memory of cells, and cloned memory of cells will be we shall be remaining with such a structure, ensuring that it has killed the antigen that had attacked the particular cell. So in a summary, when we are talking about the white blood cells, we are saying white blood cells, they have what we call, they are of two types. One, we said we have the B cells, and two, we have the T cells. When we talked about the B cells, we say yes, they are able to produce antibodies. But what triggers these antibodies? We talked of we have what we call the helper cells and the killer cells. The killer cells, the killer T cells, is there to kill the foreign body that are attacked it. But also the T cells has got what we call the memory cell. And we said the white memory cells, it is an antibody, but it tries to ensure that the particular white cells, it is able to remember that this particular antigen had attacked it before. We say the memory T cells, it lives longer than the B cells. It lives longer. Why? In case there is a similar attack, it is able to stimulate the body so that it produces the similar antibodies to deal with that particular antigen. Now, from the cells and disease control, we are saying that white blood cells is important. White blood cells is made in such a way it can be able to fight any foreign material that is attacking it. It is stimulated, it has a memory cell that is able to remember that this particular antigen had attacked it before, so it can stimulate the blood easily so that the B cell produces enough millions of antibodies to attack that particular antigen that is attacking it. It's able to produce millions of antibodies to deal with that particular foreign body that is attacking it. Now, let us see what we term as comparative anatomy. We want to mention some few things on comparative anatomy. Now, comparative anatomy compares the structures and functions of systems and organs of different animals and plants. I repeat, comparative anatomy compares structures and functions of systems and organs of different animals and plants. So in comparative anatomy, we are going to compare the structures. When you compare the structures, we shall also compare the systems of one animal with another. For instance, we can compare, if we talk of alimentary canal, we had studied about the alimentary canal. We can look at the alimentary canal of a chicken, how it looks like. We compare it with the alimentary canal of a pig. How does it look like? And the alimentary canal of a cow, how does it look like? Are they similar? Where are the similarities and where are the differences? That is when we are comparing maybe the digestive systems. But even we can compare their structure in terms of the skeleton. Are the skeleton similar or not? We can compare the front appendages, the legs. How similar are they? We can compare the leg of a rat and the leg of a human being and the hand of a human being. How similar are they? We can compare a leg of a horse and maybe a leg of an ox. How similar are they? So we are saying comparative anatomy compares the structure and functions of systems of organs of different animals and plants. And we are saying comparative anatomy is important when it comes to classification, for us to be able to classify that these animals belong to almost the same class or the same kingdom. What do we look to? This is where even people talk of evolution. They say, yes, we have seen these organisms, they have similar things. Maybe they've evolved from the same ancestor or the progeny is the same. We can only do that when you compare their system, their structures, their anatomy. So we are saying comparative anatomy has long served evidence of evolution, because many scientists believe that organs which have similar characteristics share common ancestor. So if we compare the structures, if we compare maybe anatomy, different anatomy of a human being with the one of a chimpanzee, and we see they are sharing similar characteristics, then we should say maybe they came from the same ancestor, or they came from a common ancestor, or from the same parent, whatever ancestor. Comparative anatomy also assists scientists to classify organisms based on similar anatomical structures. When we talk of anatomy, we are now looking anatomical structures. How anatomical structures of this particular organism is similar to another. So we're saying comparative anatomy will assist scientists. It assists scientists to classify organisms based on similar structures, similar anatomical structures. We can use a common example, then we shall proceed. For instance, comparative anatomy is the bone similar? Maybe we can compare, maybe if the front limbs of maybe cats, whales, birds, human beings, all these appendages consist of the same parts, yet they serve completely different functions. So they can be similar, but you find that the front limbs, whether you compare the front limbs of a mouse, you compare the front limbs of a cat, You compare the front leaves of a horse and ox. They can be similar, but you find they are doing different functions altogether. There's what we call adaptability depending on the environment. And environment has made some living organisms to adapt well, depending. So if you have maybe your hands, you are using your hands to write. When you talk of a bird, it will not use the hands to write. It can use their hands, maybe wings, and they can be able to fly. We are going to have a structure in comparison. We are going to compare how similar they are, a horse and an ox. Then we shall also compare how cats looks like a cat, the front appendages of a cat, and also we shall look front appendages of a human being, and lastly a whale, even a fish. It has got a front appendages. We want to see how it looks like, where similar they are, and how there are different functions. We have a diagram here that will be showing the radius, the ulna, and so forth. But we want to deal with this structure properly in our next lesson. So let us end the lesson here. But in our next lesson, we shall draw all the structures of a ox. We are going to draw the front appendages of a ox, and then we shall draw the front appendages of an ox. Then we shall draw the front appendages of a bird. Then we shall draw a front appendages of a human being. We shall compare with the human being. We see how similar they are, where they are different, and reasons why they are different, and so forth. So that marks the end of the lesson today. Thank you.